Okay. What is that? Why don't you use mine right here? Actually, I need one for the projector. Yeah, you can use this one. Thanks. Okay, so we're going to talk about ratios, proportions, and percentages. That's actually a pretty heavy concept. And we'll do an easy one, a medium, and hard. So 30, actually this one's considered easy because remember the grid ends go from 29 to 38. So 30 will be the second grid end, so this actually shouldn't be too bad. So recipe for making 10 loaves of bread requires 24 cups of flour. The proportions recipe to be used to make 3 loaves of bread. How many cups of flour would be needed? So basically I would just do this, 10 or 24. Notice I'm comparing loaves to flour. Equals what? 3 over x, right? You wouldn't do x over 3 because remember, I'm comparing loaves to cups of flour. What was that? I gotta still watch that movie. I'm gonna watch it in a midterm break. I'm teaching AP Calculus and we're doing limits now and the limit doesn't exist and they start laughing at Mean Girls. So. Okay, that's great. Anyway, if we cross multiply, we get 7.2 as the answer. Okay, so that's considered a basic one. Just want to make sure you guys are comfortable creating a proportion. And remember, proportions is when you have 2 ratios of equal value. So now let's look at number 16. It's kind of the same thing. So I'll read out loud. Stopping distance of a car is the number of feet the car travels after the driver starts applying the brakes. Stopping distance of a certain car is directly proportional to the square of the speed of the car. So I emphasize those words right there. You'll see why very shortly. So if you're given an initial speed of 20 miles per hour, stopping distance 17 feet, then what's stopping distance for 40 miles per hour? Now let me ask you this. Do you guys remember the formula for direct proportion? Y equals kx. But in this case, we're going to say y equals kx squared. Or, using variables are more in line with what we're trying to do. The distance equals k times s squared. Right, so what does k represent? Does anyone remember? Yeah. K is the constant of proportionality. So in this case, k equals d over s squared. So I'm still going to do the same thing as number 30, it's just the wording can throw you off a bit. So it's still the same thing, but we're now comparing distance over speed squared. So 17 over 20 squared will equal what? What was that? X over 40 squared. Or we could say D. Okay. If you use a calculator to work that out, very, very simple. What's that? No. So if you have 17 over 20 squared and multiply it to 40 squared, so the calculator can be helpful here. We get 60 as our answer. Now I caution you that the College Board is very sneaky with some of their answer choices. If you forgot to square, I know. I don't know. They just are. So you get 30. You would get 34, and then you would have been misled to picking A if you forgot to square. So just be careful. You read all the words. That's, I think, the key thing that I want to say here. So anyway, now 27. This one's a little more challenging. Actually, this should be written as a multiple choice question because 21 through 28 are multiple choice questions in PSAT. That's all right. We'll do this as a grid in. But this one's considered hard. Now, there's a couple ways you can go about it. Here's the way I like to teach it, but I can show another way if you guys want me to. You're given the total grams of a solution, right? 8 grams. And what's the ratio? So that's part to part, right? So what I like to do is say this. X represents the what? Actually, it's going to be more... It's okay. This is a term I kind of made up. I like to call it the common multiplier because it's the number you multiply each part of the ratio. And so once you know what that is, then you could get the exact amounts of each part in the solution. So this technique always works for these kind of ratio problems. So 4x equals 8. X equals 2. Isabel, are you still on your phone? Yeah, I can easily tell. All right. Thank you. So x equals 2. So that means you're going to have 6 grams of water and 2 grams of alcohol. That works because 6 plus 2 is 8, and 6 over 2 is 3 to 1. Let's look at the next one now. Do the same thing. Now the ratio is 2 to 1, right? So 2x plus x. But how many grams are in the next solution? Total grams? 12, right? I found this technique to always work, what I'm doing right now, for these more challenging ratio problems. So that means you're going to have 8 grams of water and 4 grams of alcohol. That adds to 12, and that ratio is still 2 to 1. Now we have to answer the question. What's the question asking for? Okay, so the new solution, when you mix the two together, how many total grams is that? And how much is alcohol from both? 6. So 6 over 20 is the answer. Or 3/10. If you gridded either one would be fine. Or if you put 0.3, that works. Go ahead. The last part? Okay, so were you able to understand the previous parts? So, yeah, so in this case, if you think about it, 6 over when you put the two solutions together, that's going to be total 20 grams, right? Because you have 8 gram solution, 12 gram solution. And there's 2 grams of alcohol from the first one, 4 grams of alcohol from the second one. So that's where it's 1. You want to find it, yes. You're not making it up. You're actually right. Right. Another way you could have done it too, by doing the board real fast, you could have said this. So this is going to be part to whole. This is for the 8 gram solution. So if you treat it as part to whole, then you can do like a proportion. Do it for the other one for the 12 gram solution. You can do, let me think, that would be 1 to 3. But you gotta be careful that you're doing part to whole. Because there's 4 parts in the first solution, and there's 3 parts. I'm not sure if that works for you guys, but that's another way you could have done as well. If you want to do part to whole. Or you can just do it the way I did, where you work as part to part. Okay. So moving right along. Plane geometry. So there's a significant number of plane geometry questions. So this is just more review than anything else. Shouldn't really be too much strategy. Now the cool thing is that they give you these ratios. The 30, 60, 90, and the 45, 45, 90. I decided to throw it into this problem just so we don't have to like look it up somewhere else. Just make it easy for us to reference. So So we want the length of BC. What if I dropped an altitude? Actually, let's just do a straight line. Here we go. Okay, if that's 45, that's 45, right? And if that's 45, what's this going to be? Yep. So now what we do is we use the ratios off to the right to figure out what the other side is going to be. Obviously, I know these are 2 and 2, because if that's s root 2, so s is 2. And if that's 2, then this would be 2 root 3 would be over here, because root 3 is one opposite 60 degrees, so one opposite 90 degrees is double the shortest side. So the answer is 4. So again, it's just a matter of just using the ratios. You'll get a chance to practice that. Ricky? If you have that program, you could, but not a lot of people do. I'll give you guys some programs today if we have a chance. I think we should, because I'm going to have you guys do some practice once I'm done with this page. Okay, 16. This one involves shaded areas. Shaded areas is also kind of a big deal. You tend to see it a lot. So the area of the shaded area is 20 pi, and the radius is 5. If the radius is 5, what's the area of the circle going to be? The whole circle. 25 pi. But if the shaded part's 20 pi, then what's the unshaded part going to be? Unshaded sector would be 5 pi. Or 1/5 of circle. So right here is 5 pi, so it's 1/5 of the whole circle. What angle would this be then? Remember, central angle is proportional to the area of sector. 72 degrees, because 1/5 of 360 degrees is 72 degrees. So you have to remember proportions. Proportions are a big deal in geometry as well. So if that's 72, then x has to be 18 degrees. It doesn't look it, but you don't go by looks, because it's not drawn to scale. Shannon? You can, but not a lot of people remember that. But if you remember, that's great. You could. Yeah. I'm just using proportions, because I have students they'll like freak out, like, oh, I couldn't do it because I forgot the formula. And then I look and like, you don't have to know the formula, because it's all about proportions. That's where the formula comes from. It comes from proportions. For area of a sector, yeah, if x is your central angle, so x degrees or 36 degrees times pi squared. Yeah. You can use that too if you want. Okay,